So today we will talk about two libraries on Python. One is Numpy and another is Matplotlib. So yesterday actually we completed the basic introduction to Python. So I think by now you all must be comfortable with the basic syntax of Python. So the tutorial or demonstration taken here is taken from the two sources. One is from Numpy and another is matplotlib.numpy.org and matplotlib.org. So anyway, so what is NumPy? So NumPy is a fundamental package for scientific computing with Python. Actually, NumPy is the most basic fundamental package on which there are a lot of other libraries are built on the top of NumPy. So NumPy is the fundamental package. So if you have to learn like data sciences, data processing, even image processing, so you must be comfortable working with NumPy. So NumPy is a library for handling multi-dimensional or n-dimensional arrays. So I will be talking in detail about these things. So actually, each element of the NumPy array it must be homogeneous. Like if and there is an array, the array must all elements of the array of must all elements of the array must be of the same data type. So even actually NumPy's dimension we called access. I will be covering these things in detail. And NumPy is array class. So actually in NumPy we make arrays. So array class is called ND array. So this is just an alias for array. So first thing is before starting, first thing we have to install NumPy. So for installing NumPy either, so you can use the command if you are using Anaconda Conda prompt, directly conda install NumPy, or if you are using Anaconda Navigator and from Anaconda Navigator also you can select the NumPy version whatever you want, and from there also it can be installed. So basic, like if you want to conda, so here the first you have to just activate your environment. Suppose I call geo processing. Then just conda install and NumPy. So with that very easily you can install NumPy. Or if you want to use Navigator, then anyway, suppose I go to base environment, then suppose here not installed or installed, you can search NumPy. In this NumPy is already installed. So from here you can just select NumPy and install, because in this package already NumPy is installed. So here already NumPy is installed, so you can select from here and install. So either way you can install NumPy very easily. So once the NumPy package is installed, so first thing what you have to do, first thing we need to import NumPy. So import NumPy as NP. So what we are doing here, first we are, as I explained earlier, so any additional module in the Python library you can import using import statement. So import NumPy as NP means thereafter we will be referring NumPy as NP module. So instead of typing every time full NumPy, so NP will be a shorthand for the NumPy. So this will save us from typing, and this is a standard convention everywhere in the Python community. They will refer NumPy as NP only. So whenever we are writing NumPy as NP means now NP will be shorthand for NumPy. So either this we can do this also, but anytime you are calling any function of the NumPy, then you need to write full NumPy dot something. So if you write NumPy as NP, now you can refer to with NP shorthand. So now next is how do we create an array. Suppose this is a sample example. So np dot arange. So NumPy has a function called arange. So this will generate the numbers from 0 to 5. So that is a one-dimensional array. So with this we'll create. I will come in detail one by one. So this looks like a list of Python. This looks like a Python's list data structure. So now we'll cover what are the why actually it is why the, if already if it looks similar to the Python list, then why a separate NumPy library has been created. Now, what are the differences between Python list and NumPy? NumPy gives an enormous range of fast and efficient ways of creating arrays and manipulating numerical data inside them. Actually, Python lists are slow compared to the NumPy because NumPy basically is implemented in C and Python bindings are available for this. So NumPy basic library is C. So NumPy gives gives you a range of fast and efficient ways of creating and handling matrices. While a Python list can contain different data types within a single list, as I explained, but elements of NumPy must be homogeneous. NumPy arrays are faster and more compact than Python lists. And NumPy arrays consume less memory and are more convenient to use compared to the Python lists. So what is array? So array is the central data structure. So any array is the central data structure of the NumPy library. So what is an array? Array is a grid of values. So an array we can like strings or lists. Array also can be indexed by a tuple of non-negative integers or even negative integers also we can refer like last, or even we can index the array elements using booleans. So every array will be having a rank. So the rank means how many dimensions that array has. So 1 dimensional, 2 dimensional or 3 dimensional. That is the rank of the array. So then we define one more term that we call shape of an array. So shape of an array is the tuple of integers giving size of array in each dimension, along each dimension. So this we'll see with an example what all these parameters mean. So let's first thing we create a basic NumPy array. So how do we create a NumPy array? So we can initialize a NumPy array from a Python list. Or so suppose if we are creating a one-dimensional array, we can create it using a simple list. Or suppose if we are creating a two-dimensional array, we can create two-dimensional array using nested list. So this is the first example of, so first thing we need to call the np.array function of the NumPy. So suppose here we are writing a equal to np.array, then this is the list of elements. This is a list. So 1, 2, 3, 4, 5, 6. So we are creating a one-dimensional array, one-dimensional NumPy array. So if we see that so array has 6 elements. Now we have created an array. So now we can access the elements in array using square brackets like lists we were using. So any element if you want, and the first index starts at 0, 1, 2, 3, 4 and so on. So suppose if I print A0, it will give me first element from the NumPy array. And similar way we can create two-dimensional array. So in two-dimensional array we will have two square brackets. So every row will be separated with a comma. So there you can see that this is a single array and here we are two arrays. So every row is separated by a comma and these are the elements. So this is a two-dimensional array. So if you see that this is a two-dimensional array. This array has 3 rows and 4 columns. Now suppose if you want to similar to one-dimensional array, two-dimensional array also can be indexed. So A0 will give us zeroth row. So if I give A0, it will print all the elements first row. So this is how do we initialize a one-dimensional or two-dimensional array using the lists Python list. Now this array class is also referred as ND array or n-dimensional array. So like every array it is one-dimensional, two-dimensional or n-dimensional. N-dimensional array means array with any number of dimension. It can be 3, 4, 5, 6 anyway. So NumPy ND array class is used to represent both matrices and vectors. So ND array is the base class. This class only is used to is used for representing matrices as well as vectors. So what is vector? Vector is an array with a single dimension. So this we call if a one dimensional array we call vector also. Actually in NumPy there is no difference between row vector or column vector, though that is a simple thing. A matrix is an array with two dimensions. So one dimensional array we will call as, or even any array without any dimension. So suppose that is we'll call scalar, or one dimensional or two dimensional array also. Two dimensional array we will refer as matrix. So three dimensional or higher dimensional array generally there is term called tensor. So a 3D or higher dimensional array are generally referred as tensors. So now once we have created an array, there are some attributes to an array. So what is an array? So array is usually a fixed size container of items of the same type and size. So all the elements of the array will be of same type. So if you are creating an array, all the elements of the array must be integer, float or complex numbers. Next attribute of the array is the shape of the array. What is the shape of array? Shape of array is number of a tuple, that is number of elements along each dimension. So actually in NumPy's terminology, even a dimension is called axis. So let's see what are those attributes. Suppose here we are creating an array using np.arange function. So np.arange, then we are creating numbers 0 to 19, and just I'll talk more about this reshape function. So then we are reshaping it to 4 by 5, means 4 rows, and so arange will create a one dimensional array. With reshape function we are rearranging it in 4 rows and 5 columns. So if you see this, now let's access each attributes of this array one by one. So first, suppose if you want to extract how many dimensions are there in this array. So for that there is an attribute endim. So if a.endim, we do see it is a matrix, it has two dimensions. So a.endim gives us 2. So rows and columns. Now let us talk about shape. Shape, as I explained, shape is number of elements along, shape is a tuple describing number of elements along each axis. So actually rows are the first axis and columns are the second axis. So if you see a dot shows shape, it says 4, 5. It means there are 4 rows and 5 columns in this particular array. The shape of array is 4, 5. There are 4 elements in its first axis and 5 elements in its second axis. Let us see size. So size describes how many total elements are there in this array. So there are 4 into 5, 20 elements in the array. So suppose now if you want to access what is the data type of these elements. So a.dtype.name, if you give, it says 32-bit integer. And if we want to access the size, what is the size of each of the individual item? So 4 bytes. So each element takes 4 bytes in the memory. So this was the basic introduction. So this is similar thing like array creation that anyway we have already covered. So an array can be created using the function. So first, to create an array, we have to use the function np.array. So np.array, then we have to pass it the list of elements which we want to create. So suppose np.array if we are creating. So visually you can see that in the memory it will be created like this, and a one-dimensional array with 3 elements. So similar way, suppose if instead of integers you want to create an array of complex numbers. So the similar way you can create np.array, then elements, this is 2-dimensional array, there this one, and d type. So second argument you can pass to the np.array function is data type. So if you type d type equal to complex, so these numbers will be interpreted as complex number. So a complex number, real and imaginary parts. So suppose 1, so this has only a real part. So we are not passing any imaginary part to this. So if you see it, it says that this is an array with 1 plus 0j. So actually there is no imaginary part here. So it is taking it as 0. So 1 plus 0j, second element 2 plus 0j, 3 plus 0. Suppose if you have imaginary part also available with you instead of 0, then you can call complex function complex, you can say complex 1 comma 1, like each element will be a complex type. So complex, this is the real part and this is the imaginary part. Similarly, real part, imaginary part. Now if you see, here you can see that in the first element is 1i plus 1j, second element is 1i plus 2j, but third element anyway we have not made it as complex, so imaginary part is taken as 0, 3 plus 0j, 4 plus 0j. So this way we can create basic arrays. Suppose now if you want to create arrays with an array with all zeros, so you can use a function called np.zeros, and you can pass the shape of array, what type of array, what shape of array you want to create. So np.zeros 3 comma 4 means 3 rows and 4 columns with all 0 values we are creating. Similar way we can create all ones or some suppose empty near 0 values. If you want to create, np.empty function is there. Similar ways, if you want to create 3-dimensional array, you can create 3, or this is a simple, this is a arrange function with 3 elements. So start, end and increment. So every element will be increment 10 to 10, 15, 20 and 25. In similar way, suppose if you want to create, and there is a function called np.line space. So this what it will create. So this takes 3 arguments. First is start, end and how many elements. So it will create 9 elements starting from 0 to 2. So the difference it will calculate automatically. And suppose instead of 9, if you want to generate 20 elements in range 0 to 2, it will automatically calculate the difference what it's supposed to do. For floating point numbers, we can use np.line space function. So anyway, this I have already explained. So data type of your element also you can specify. Suppose if you want to create 64-bit integers, so then like all ones, np.1, then d type you can define np.int64. So X will create. Now similar way, suppose if you want to create an array with random numbers and so on, so there are many functions available. So that we can use for initializing the array to different states. So there is a function called rand integer. So with this you can generate random arrays. So this will create this will generate the random numbers in range 10 to 101, and size as we have given 6. So this will create a 1-dimensional array with 6 elements in range 10 between 10 to 101. Similar way you can generate random numbers between 0 to 1 using np.random.rand, or similar way 2-dimensional array you can create by 2 by 3s and so on. So this way we can create 1-dimensional, 2-dimensional or 3-dimensional arrays and initialize values to those arrays. Now next, suppose we have created an array. Now suppose if you want to add, remove or sort the elements inside an array. So there are multiple functions available for that. Suppose you have created an array with this value. So suppose now if you want to sort it, so then there is a function called np.sort. Actually this I forgot to tell you. In Jupyter Notebook, so suppose if you type tab like numpy and you want to see which all functions are available in numpy package. So np.sors and tab if you type, then it will list the functions starting with s or whatever. So short if you type here, and if you press there shift tab, so it will display you the doc string or document string of the function. It will display here. You can access the details of the function. You can read about the function. So this way. So with tab, np.s and tab will list you the functions available with this. And with shift tab will open HTML help of the function. So this you can read. If you have any doubt about the function, you can read from here. So this function np.sort, this will sort the elements of A. So now here you can see that initially A was 2156. Now the elements of the array got shorted. So suppose now if you want to concatenate two arrays, so for that there is a function called np.concatenate. So with that concatenate, you can concatenate two arrays together. So now here you can see that all the elements got. So A was 1, 2, 3, 4, 5, B was 5, 6, 7, 8, and we got a new array with 1, 2, 3, 4, 5, 5. So similar way we can concatenate two-dimensional arrays as well. So these are two-dimensional arrays. So 1, 2, 3, 4, 5, and 6. This way you can concatenate two arrays very simply. So you actually, if you are if you have used any other programming language, there you need to write loop for this to this, I equal to this and on. Here with just a single statement, these functions can be achieved. This is like a simple mathematical expression. Just you write a plus b here, then you get the result. Now let's see how do we manipulate the shape of an array. So that I'll talk in detail about the reshape function. So first suppose we are creating an np.arange function. So this will create a one-dimensional array of 20 elements starting from 0 to 19. Now suppose this is a one-dimensional. Now if you want to reshape it, so you want to reshape it into 4 rows and 5 columns or any other combination. So for that there is a function called reshape. So a.reshape, what it does, it will reshape the given array to other, and it returns a new array. So it doesn't modify the existing array, it returns a copy of the array. Basically what we are doing, either we can assign it to B, so then B will be an array, two-dimensional array of 4 by 5, but A remains same only. So even if I print A will be same. So A is similar only. So reshape will return a new function, new array. So B shape, you can see it has become 4 by 5. Now once you have a two-dimensional, suppose two-dimensional array you want to flatten into a one-dimensional array. For that there is a function called ravel. So ravel with reshape you can change the shape, and ravel you can make a two-dimensional array to one-dimensional array. So with suppose b.ravel, if I call, it will convert it to a one-dimensional array. So now here you can see that it was two-dimensional, now it has been turned to a one-dimensional array. Similar way there is a function called resize. Actually what is the difference between reshape and resize? Reshape was not changing the original array. So with resize changes the original array itself. So if you resize if you call a.resize, A itself gets changed to the defined shape. Now let us see how do we add a new axis to an array. Suppose we have a one-dimensional array and we want to convert it to two-dimensional array, or we have a two-dimensional array and we want to convert it to a three-dimensional array, and so on. So for that there are two functions available in Numpy. One is np.newAxis and another function is np.expand or expand dimensions, that are used to increase the dimensions of the existing array. So using np.newAxis will increase the dimensions of our array by one dimension when used once, or if you want again you use, then one more dimension will be increased. This means that 1D array will become 2D, 2D will become 3D, and so on. So let us see with an example. Suppose this we are creating a one-dimensional array of 6 elements, A equal to this. Now let us see the shape of this. This is 6 comma. So this is a one-dimensional array with 6 elements. Now suppose if you do this A np.newAxis colon, so this will change this one dimension, this will add a new dimension to this A array, and that will be assigned to A2. Now if you see to A2, now see here A was with a single square bracket, now it has become two-dimensional array with just one row. So here what it has done, it has added a row row to this existing array. Now if you see the shape this way. So similarly, you can explicitly convert a one-dimensional array to a row vector or column vector. Suppose if you, this is an array, if you write a dot new axis comma this will become a row vector. Or if you write semicolon dot at np dot new axis on the right side, it will become a column vector. So now you can see that this has become a two-dimensional array with a single column. Similar way, we can expand the dimension of the array with np dot expand dimension function axis. So in which axis you want to expand the dimension, axis equal to 1 means column. So this will create a column vector from this b. B will be a column vector. Similar way, suppose if you want to convert it to a row vector, we can pass it to axis as 0, then it will become a row vector. So one dimensional array has been changed to two dimensional array. So this way you can add a new axis to an existing array. Now let us see how do we how do we perform some basic operations on two numpy arrays. So arithmetic generally the arithmetic operators on arrays apply element wise. So a new array gets created with the result. Existing array remains same. A new array gets created after applying that particular operation. So once we have created arrays, we can start to work with them. Let's say suppose this will be like, suppose we are creating one array. So this is data with np, so with two elements 1 and 2. Suppose another array we have created with 1 ones. Suppose if you write data plus ones, just we write data plus ones, so this operation will be applied, and element wise these two arrays will be added together. So there are two arrays, one is having, these two are one dimensional arrays, and the one is having elements 1 and 2, other one is having element 1 and 1. Suppose if you just write data plus ones, then both of the arrays will be added element wise, 1 plus 1 and 2 plus 1, and we get a new array with 2 and 3 values. This is the same code written. So first we have created an array, one dimensional array with elements 1 and 2, and one second array with ones. So suppose if you want to add these elements, these arrays element by wise, just we write, instead in other programming language we write loops for I equal to this to this. So in NumPy we can just write one statement, data plus ones, these two arrays, then it adds both elements element wise. Similar way, suppose if you want to subtract, just write data minus these two, first array, second array. Multiplication similar way can be achieved using this. Then there are other functions available to this function. Suppose we have an array and so you want to add all elements of the array together. So there is a function called sum. So a dot sum will add all elements of the array. So 4, 3, 2, 1, added it and 10. So suppose if you want to add, suppose you have a two-dimensional array and you want to add it column wise or row wise all the elements. So you have to pass the axis. So axis, as I explained, every axis, each dimension of the array is called an axis. So first rows are the zeroth axis. The similar way columns are the second axis. So suppose if you want to, this is array B. Sorry, this I think some problem got in this array. So this and B is a two-dimensional. Now suppose if you want to add all the elements of the array row-wise or column-wise. So suppose if you want to get the sum of all the rows, so you can pass b dot sum and an argument to the sum function as axis, around which axis you want to calculate the sum. So if you want to calculate the sum row-wise, so actually row will be axis 0, columns will be axis 1. So if you see that, if you pass it, so 3 and 3. So you can use row-wise, these got added. Similarly, suppose if you want to calculate a sum of the all elements of your array column wise, then you can pass axis argument as 1. So here you can see that 1 plus 1 and 2 plus 2, these elements got added. So now there is a concept of broadcasting in NumPy. Suppose in linear algebra, if you want to add or subtract or multiply two vectors or matrices, linear algebra requires that the two operands, whatever two matrices, have the same dimension. Right? So both the matrices must have the same dimension. Suppose if you want to add or subtract two matrices in linear algebra. Furthermore, suppose if you want to multiply two vectors or matrices, then linear algebra imports certain restrictions on the multiplication. Or there may be times when you want to carry out some operation between an array and a single number. So for those two may be of a different size. So for example, suppose you have an array that contains information about distance in miles, but and suppose if you want to convert it to that miles to kilometers. So suppose if you have an array and you want to convert it to kilometers. So that we will see with an example of what is broadcasting. So suppose you have an array which contains the distance in miles. Suppose now if you want to convert that distance in from miles to kilometer, means you want to multiply each element of the array using a scalar number. So suppose, but linear algebra says that both suppose if you are multiplying, adding or something to one-dimensional array, so both the elements should have the same shape. So but what does NumPy does internally? So this is our original array, and we are multiplying. If we are multiplying it with a scalar, so this scalar will be expanded to this. So this is broadcasting. So what NumPy is doing, NumPy understands that the multiplication should happen with each of the cell. So what it will do, it will expand that to the shape of this first array. So this is called broadcasting. So broadcasting is the mechanism that allows NumPy to perform operations on arrays of different shapes. Here we can see that these are the two arrays having different shapes. So what it will do, it will reshape the second array for matching it to the first array. So this is called broadcasting. So here 1.6 will be expanded, and then 1.6 will be each element of this array will be multiplied by 1.6. Similar way, you can see that suppose if we have here a similar way, suppose if we have an array with data that is two-dimensional array, and we have another matrix with 1 and 1 element. So this 1 by 1 will be expanded to match this. So this way, this is broadcasting. Similar way, we can apply any other operator to the. So this will be apply power. So all the elements will, all the arithmetic operations we can apply element by this operation will be applied on each element of the array. Suppose if you want to raise every element's power, you want to raise by 3. So b raised to the power 3 you want to calculate. This instead of loops you can write b raised to the power 3. Or suppose if you want to calculate cosine and multiply it by ten, so you can do this way. So suppose if you want to get, you have two arrays, you want to calculate the product of two matrices. So just you can write A cross B. So A cross B will do element wise multiplication, and suppose if you want to dot product of two arrays A dot B, or you can call A at the rate B. This will calculate matrix product. Suppose similar same things are available if you want to calculate A into A cross 5. So every element you want to multiply it by 5, or random. If similar way you can calculate sum, or if you want to calculate max of an array, min of array. So multiple functions are available. Except to this, there are some universal functions like you can calculate sine, cosine, square root. So multiple functions are available for working with NumPy arrays. Next function is, now let's explain how do we index, slice or iterate over a NumPy array. So actually in one dimensional array there will be only one index like 0, 1, 2, 3, 4 and 5. So for if you are going for multi-dimensional array 2D or 3D, so for 2D and 3D arrays there will be a index for every dimension. So suppose if you want to access an individual element of a matrix, so then you know the row number and column number of the element which you are going to extract. So for multi-dimensional array, one dimensional array there will be a single index, and for accessing elements of the multi-dimensional array you need the index in each of the axes. So now suppose we are creating an array. So this is a one dimensional array. So A0 will give you the first element of the this one dimensional array, A0. Similar, A0 will give the zeroth element. So 2 will give the second element of the array. So A minus 1 gives the last element of the array. So it will give 81. So this similar way like yesterday I explained for strings, slicing also can be done. Suppose if you want to get multiple elements. So A2 colon 5 will retrieve second, third and fourth element from the array. So 4, 9 and 16 will be straight. Sorry. So now suppose similar way, suppose if you want to do assignment, suppose 0 to 6th, or suppose you can pass this way also. So with column M, if there is nothing, if any item is missing before the column, so it will be taken as 0. So it will extract the element 0 to 5. So A5. Suppose on the right side if it is missing, so then it will go from 5th element to the last element. So if anything is missing with the column, so that if it is starting, if starting is missing, that will be assumed as 0. Last is missing, that will be assumed as last. If both side nothing is there, means then entire array will be printed. There you can see that entire array is printed. Now suppose similar way you can, as third argument you can pass, say this is the steps. So 0 to 6th, every second element equal to minus 1000. So 0 to 4th elements will be assigned minus 1000 value. So here you can see that this way you can multiple values you can change with a single statement. So starting, ending and the increment. So similar to one dimensional array, suppose if you want to access you want to index multi-dimensional array, so you need to have one index per axis. So this is an example. Suppose data, we are creating a two-dimensional array. Now if you want to access any element of the array, so now here there we are passing a single index. Now we need to pass here two indexes, one for row and another for column. So both the indexes will be separated by comma. So suppose if I write data 0, 1, so it will extract 0th row first column. So it will print 2. So this is like, this was our data visualization. If I write 0, 1, so 0th row first element. So for first axis I am passing index as 0 and second axis 1. Similar way, suppose if I write data 1 colon 3. So here I am passing a single index to the array. So if I am not passing a second element, so second index. So if I am not passing any second index, it assumes that all elements of the second axis. So if I write data 1, 3, so it means first and second row and all columns, because we are not passing any value to the column index. So it will extract first and second row and all columns. So here you can see that these 4 elements will come. And the second thing is like data 0, colon 2 and 0. So what does it means that 0 and first row and 0th column. So this will pass this. Or similar way, suppose if you want to get all rows for 0th column. So this will give us all rows for 0, 1, 3, 5. So for a multi-dimensional array, you need to pass each index per axis, and suppose every index will be separated by comma. If any of the index is missing, that is assumed to be all the indexes. So this way we can be index. So similar way we can, instead of integer, we can use Boolean indexing also for indexing an array. Suppose this is an array. Now in this array, suppose if you want to find the elements which are greater than 2. So if we just write a greater than 2, then it will return the array of the array as the same array which will be having the same dimension as of the a, but returning true wherever a is greater than 2, otherwise false. So here you can see that this has returned an array of same 3 by 2, and first element, if first element is less than 2, so it has returned false, false, and 3, 4, 5, 6 are greater than 2, so there it has returned true. Now if you want to get those elements, so print, suppose a dot boolean index will return the elements from the array a wherever boolean index is true. So this way you can do Boolean indexing. So 3, 4 and 5, 3, 4, 5 and 6 elements is written. So suppose if you want to, this will be helpful. Suppose if you have read an image and you want to extract the pixels which are above certain threshold value. So which are those pixels? Suppose if you want to know, so with this Boolean indexing, you can extract those pixels very easily. So similar thing with a single statement also. Suppose instead of writing this way, similar result you can achieve just by printing a cross 2. A greater than 2 also will return the same result. Instead of assigning a Boolean index separately, you can do this way. Suppose you want to get a less than 2, so it will return a single element less than 2. So similar with, now suppose this is an array x, this has 4 elements. Now suppose what do you want to do? You want to add 20 to the all non-negative integers. So with the single statement you can achieve that. So x less than 0 plus equal to 20. So this will, first it will x less than 0, it will extract all the elements which are less than 0, and plus equal to 20 will add 20 to each of these elements. So with the just single statement you can add. So here you can see that this -1 and -2 got incremented by 20, other items remain same. So similarly there is a function like np.non-zero. What np.non-zero function does, it prints the indices. Suppose if you have an image and you want to get the indices of, instead of numbers you want to get the indices, like at which locations those pixels has. Suppose you read an image and you want to know that this in this 2-dimensional image or which pixels have values less than something. So just instead of their values you want to get their indices, their location if you want to get, then you can use the function non-zero, np.non-zero. So np.non-zero, what it will return? It will return an array of indices. So it says that 4 elements. So 0th row, 0th element, 0th row first element, 0th row second element, 0th row third element. These elements are less than 5. Or suppose if you want to print here which elements are less than 2, 3. So it returns the indices. Instead of returning the items, it returns the indices at which location the elements are less than 3. So np.non-zero function. Now this has returned an indices. So suppose if you want to access the values, so a with the square brackets you can access the values as well. So 1 and 2, these are less than 3. So either if you want to access indices or if you want to access values. So similar way, suppose if you want to combine multiple conditions together, like you want to check for two conditions. So if this is an array, so you can combine with using AND or operators. So you have an array with values this. Now if you want to find the elements which are greater than 5 or equal to 5. So you can write either A is greater than 5 or A equal to 5. I mean, this is a simple condition, but this way you can combine multiple complex conditions together and extract the values from the array. So these operators actually will be quite useful during image processing, where you want to like if maybe required that you want to mask the pixels which have values beyond threshold or less than threshold, or like multiple conditions you want to combine together. So this way with the single statement you can extract those pixels and mask or whatever you want to do. Similar thing you can be done. Similar way, suppose if you want to apply some if else like statement to your array. So for that there is a function called np.var. np.var will apply if else to the entire array. Suppose this is, we have an array A. Now suppose if what we want to do, we want whenever if the number is less than 5, we want to retain it as it is, and if the number is greater than 5, we want to multiply it by 10. So that just can be done using a single statement, np.var. np.var, first argument to np.var is the condition, what condition we want to check. So np.var, wherever A is less than 5, the new value will be A only. If A is less than 5, the new value will be A, otherwise that will be multiplied by 10. So it will return a new array. So here you can see that wherever A was greater than 5, it has multiplied it by 10. So with np.var with single statement that can be done. Similar way we can do like whatever condition np.var, this is A less than 4, we will assign it A, otherwise -1. Or suppose np.mean, include wherever A, like suppose you want to calculate the mean of pixels which has the value greater than some threshold. So what is the mean? So np.mean, then inside that the condition you can pass. So similar way you can pass. So and Numpy will be very handy during our later lectures, where we will do basic image processing, we'll read image plotting and other things. So if you, so first at least you should practice the Numpy with yourself, so that will be helpful in subsequent lectures. So once array is created or image, so once you read an image will be a matrix of numbers. So now let us see how do we visualize these matrices. So for visualization we will use a library called Matplotlib. So Matplotlib is a Python plotting library that produces production quality figures, and it provides very easy interface. It's simply just by writing a one line of code you can create very nice visualizations. In this lecture we will just cover the pyplot module of the Matplotlib library. So what this is, so anywhere once you create a matplot, you want to create. So in Matplotlib there are two things that two terms we will be using. One is called figure and second is axis. So figure is the entire screen, or this is like this complete thing is a figure. So there is always a current figure and axis. So figure is this complete figure and axis is the area where this graph will be plotted. So figure is this complete figure. So we will be adding access to this figure, or we may add some labels and other things. So this is the complete figure, and axis is the area where we are plotting, and these are the axis. So there is a difference between axis and axis. So AXES or AXIS. Axis is like x-axis or y-axis. Then axis is the area where the data will be drawn. So actually there is a figure over the figure, axis will be drawn and axis will contain axis. So for creating a plot, first let us see how do we create a plot. So for first thing, there are two ways we can use Matplotlib. One is first we can create explicitly figure, and on the figure we can figure then axis, on the axis then we can plot the data, or by default PyPlot automatically creates and manages those figures, and just we need to call the plot function on those figures. So this is according to your convenience, you can use either of the approach. Either you can first explicitly create figures and add access to them or data subsequently, or let PyPlot itself make the figures, and you just need to you as plots to that. So first thing what we need to do for making plots, so first we have to import the PyPlot package. So inside this PyPlot is a module in Matplotlib. So first we have to import matplot.pyplot as plt. Now what we are doing, we are creating an array 0 to 10 with x-axis 0 to 10 with 0.2, and in y-axis we are calculating the sign of that x. So if we see here x and y, x is this 0, 0.2, 0.4, 0.6, 0 to 10 with every increment 1, and this will be the y. So now first we will create the plot using the first approach, where we will explicitly create figure and axis, and on those axis we will plot the data. So this is the simplest way to create. So for creating a figure and axis, first what we need to call from the PyPlot or plt. Now PyPlot we are referring as plt. So plt.subplots. So plt.subplots function creates a figure and an axis. So we see there this plt.subplots will create a figure and axis. On figure and axis. So anyway, figure is the complete figure on which the axis will be drawn. Now on the axis function we have to call the plot function on axis. So ax.plot, and there is this, we need to pass the argument. So in x, what is the x-axis? X and y will be numpy arrays. So this will be x and y, and what label you want to give. So this way very easily you will see that a plot gets created in x-axis 0 to 10, and y the sign of x. So first we need to create with plt.subplots, that will create a figure and an axis, and then on the axis we need to give the data what we want to plot. So x and y. So same thing can be achieved using a single line. Suppose if you are, instead of creating explicit figure and axis, either then you can directly call in the plt module plt.plot function. So here we created first an axis, and in that we called the plot function, but directly on the plt.plot itself you can create a plot. This is the second approach, where with a single statement you can create the plot. So same thing can be achieved using this. So just you have to do here, the figure and axis will be taken care by Matplotlib itself. So Matplotlib will create figure and axis implicitly, so you need not create separately. So either of the approach, whichever is comfortable to you, you can use. Both the approaches have some pros and cons. You can just read details about this and follow which is more convenient to you. So we will be, in the demonstration we will be using the second approach, where we will use the figures and axes created by Matplotlib plt or PyPlot package itself. We will not create explicit axis and plots. So now suppose instead of one graph, now you want to create multiple graphs. Now suppose we create two datas. Well, anyway x is same, and in y we are calculating sine and cosine. Now suppose we have two datas to plot, x-axis remains same and y-axis has two elements. So this way we can we can create the data anyway. Y sine is equal to np.sine of x and cos. Now similar thing, like now we have to call the functions. plt dot plot. What plt, actually plt is like a on the same axis it will be drawn. So first thing, plt dot plot, x value, x is x only, in for y sign, and label we want to is sign, and width of line, another argument we are passing as 4, and again we are calling the plt dot plot on the, then on the same axis. Actually by default it creates a single axis, so x is x, still x only. In second argument we are passing as cosine of y, and label we are giving as cosine. And actually in the plt there are other functions like x label, y label, title, legend, and finally we have to call the close function. So this way two elements, see actually one is this, and second, for the first plot we have passed the argument line width as 4. So here you can see this is a thicker line compared to this. So this way multiple element, multiple datas you can plot on the single plot. So sub so this is a actually on we have, this is a complete figure, and figure with a one axis, not axis. Axis, there are x axis and y axis, but figure with a one axis. So one axis, in one axis we have created two data plots. Now suppose instead of one you can create actually multiple axes as well. So for that creating multiple axes we have to call a function plt dot subplot. So subplot creates multiple axes. So suppose instead of one you want two plots, one more plot side by side, or these first data in one plot and second data in the second plot. So for that we need to call subplots function. Again we are generating the same data. Now here what we are doing, instead of calling plt dot plot, first what we are calling, we are creating a subplot. So subplot creates an axis. So what we are going, plt dot subplot, it takes 3 arguments. First is how many rows. Now we are creating a figure with, this was a figure with a one axis. Now we will create a figure with multiple axes. Suppose we are creating a figure with 2 axes. So plt dot subplot function takes 3 arguments. First is how many rows of and how many columns, and which is then the number of, so which plot. Suppose this is creates 2 plots. So here you can see that we have created 2 axes in a figure, 2 axes, axis 1, axis 2. So we have arranged them in 2 rows and 1 columns, 2 rows and 1 column, and this is the first plot of that 2 rows and 1 column. This is the first plot, this is the second plot. So 2 rows, 1 column, and first plot. So first it will take that, implicitly takes that axis, and in that axis what we are drawing, x and y sign, and in the second plot we are plotting x and y of cosine y. So instead of this, if you want to 1 row and 2 columns, one row, 2 columns, and this will be the first plot and this is the second plot. Now this will be to 1 row and 2 columns. So with plt dot subplot you can create multiple axes in a figure. So this was the basic introduction to the plot. Now let us see how do we plot images, or how do we visualize images using Matplotlib. So for this actually I have a image of Tehri, some satellite image of the Tehri that is converted to JPEG. Let us visualize the image using Matplotlib. So this will be using in the subsequent lectures for seeing the data with this function. So first thing, actually for reading an image, today we will just use a Matplotlib only. Tomorrow onwards we will use another libraries for reading the data and processing. So for that there is a image module available in the Matplotlib. So first we need to import that. So we are importing matplotlib dot image at mpimg. So this mpimg function, mpimg module has a function imread. So what imread reads an image. So it will read an image and return the image as a numpy array. So if you see here, So IMG, it has, so anyway, an image is represented internally. This is a 3-band image. So it is represented as three-dimensional matrix. Actually, channel number also is there. So with IMD, now suppose if you want to visualize how the image, how these arrays look, so directly on the PyPlot module, plt.imshow, there is a function imshow. So for plotting one-dimensional arrays, NumPy arrays, we were using plt.plot. So suppose if you have two-dimensional array or image, or two or three-dimensional image, then you have to call imshow function. So plt.imshow. So this is the, with this, first we have to read the image, then with plt.imshow. Imshow is for displaying the image. We can display the image. Suppose instead of this particular, this is an RGB image. So suppose if you want to, if you have a, this is a 3-band RGB image. Suppose you have a 1-band image and you want to apply some pseudo color scheme to the image plot, so that you can easily visualize your data. Suppose let us see the image. So image, we have read it. Let us see the shape of the image. So image, it says that it has 3057 rows and 3852 columns, and it has 3 channels, R, G and B. Now suppose if you extract, suppose if you want to extract red band from the image. So as I explained, so now we are extracting the data, IMG, all rows, all columns and 0 third axis. So this will extract the only red band data from the image. Now if we see, this is the 3057 by 352. Now suppose if you call plt.imshow on this, this is the data for red band. Now suppose if you want this, by default it has used some color map for displaying this image. Suppose if you want to change this, so then plt.imshow function takes another argument like cmap. So cmap, color map, has different color maps. So suppose if you want to display it as a terrain color map, so that we can see that the visual pseudo color scheme slightly changed. So to this color scheme, suppose if you want to see the color scale also is that, so you can just call plt.colorbar. So plt.colorbar will display a color bar alongside the displayed image. So similarly, suppose this contrast is not good, so then you can enhance the contrast of your image for better visualization. So for that, suppose if first thing we can plot the histogram of the pixel values. So for that, plt.hist generates the histogram of the values. Then first we need to convert this 2-dimensional array to the 1-dimensional array. So we can convert it with using ravel function. And suppose if we want to make the histogram with 256 bins, so that way we can generate the histogram of the image. This will be the histogram. As you see that the most of the pixel values are lying in the range 0 to 0.3. So suppose if you want to clip all the values outside this range, so then what we can use, to the imshow function we can pass another argument, that clip limit. So clipping limit 0.1 to 0.3. So all the values less than 0.1 will be converted to 0.1 and greater than 0.3 will be converted to 0.3. So with this argument, so now if you visualize the image, so here you can see that, so you can see that you can make out the difference. This is the image which has clipped to certain ranges. So this way, suppose all the bands also you can visualize using the same function. So here all the 3 bands has been visualized. So with plt.imshow we can visualize the image using, we can change the color map or number like pixels you can clip to certain values, like you can enhance the visualization and so on. So here you can see that we have extracted red band, 0th band, first and second. So tomorrow's lecture we will explain in detail. We'll be using the different library for that. So that's all for today. Thank you very much.